Alright, this video is going to cover how to go through ionic nomenclature. Ionic nomenclature are the rules that we use when we want to name an ionic compound. Ionic compounds are going to be compounds that are between a metal and a nonmetal. And they're going to be compounds that are formed between charged particles. And as we've seen in class, those charged particles, the metals, are always going to be the positively charged, and the nonmetals are going to be negatively charged. Overall, we always want to keep in mind that ionic compounds are going to have an overall neutral charge, even though they're made up of the metals that are positive and the nonmetals that are negative. They're going to combine in ratios so that the compounds balance out. When we name these compounds, it's really pretty simple. There's a couple different circumstances. The first will just be simple binary compounds. And these will be between metals that are in one of the first two columns of the periodic table, the alkali metals and the alkali earth metals. So, for example, here we have a compound between sodium and oxygen. This is a simple compound to name. What we're going to do is we're going to name the metal first. Oops. Then the nonmetal. The nonmetal is going to, the name is going to change. It will always end with the suffix "ide." So for this example, it'll be sodium, and instead of oxygen, it'll be oxide, sodium oxide. When we name ionic compounds, we never need to indicate how many of each element there are, because if we start with the name and work backwards, because the compounds are neutral, it's evident how many there are. We don't need to name them like we would with a covalent compound like carbon dioxide, or we're never going to have prefixes telling us how many of the elements that we have. So let's look at another example. Here we have this is a compound between potassium and sulfur. The name of this is going to be potassium. Instead of sulfur, it's going to be sulfide. Okay, so just some common endings. Nitrogen becomes nitride. Oxygen becomes oxide. Sulfur sulfide. Chlorine becomes chloride. And you can pretty much figure out the others. That's pretty simple. Now, if we wanted to work backwards, what if you were given the name and then you had to figure out what the formula would be? So let's look at one like this: barium phosphide. Barium phosphide. So I know that that's going to be between a barium element, barium, and between, it's not phosphide, but it's phosphorus, P. All right, and we know from our work earlier in the week that depending on what column that these elements appear in, that's going to help us determine the charge. Barium is always going to have a 2+ charge. Phosphorus is always going to have a 3- charge, depending on what column they're in. And so what we need to do, we need to figure out what ratio these combine in so that they balance out, so that they're neutral. So one way that you could think about that is with a teeter-totter. And we can add 2 plus charges and 3 minus charges. We need to have enough of each of them so that both sides of the scale balance out. Right now I would have more negative than positive, so I would want to have another 2 plus. This would still be unbalanced, having a 4 positive charge and a 3 minus charge. It would still be imbalanced with a negative 6 and a positive 4. But if I add one more 2 plus, now I have a 6 positive charge and a 6 minus charge. That would neutralize. The formula here is going to be 3 bariums and 2 phosphorus. So barium phosphide is going to be Ba3P2. Another example is aluminum fluoride. Okay. Aluminum is always going to be 3 plus. Fluorine, 1 minus. This one becomes more simple. It would take 3 1 minuses in order to balance out with a 3 plus. So for this ionic compound, it's going to be aluminum with 3 fluorines, and that'll be our answer, AlF3. Okay. That's how we're going to solve simple binary compounds. Things can get a little bit more complex when we start dealing with transition metals. Binary compounds with transition metals. Okay. Transition metals, if we want to look at the periodic table, the transition metals are going to be the metals that occur in the middle of the periodic table. And these become more challenging because they can have multiple charges. Transition metals can have multiple positive charges. And so depending on which form of the transition metal we have, the compound might be slightly different. And so to indicate the charge on a transition metal, in the name, when we write out the name, we're going to use Roman numerals to indicate the charge. So for instance, example, lead 2 is lead with a 2 plus charge. If we had something like chromium 3, for instance, is going to be chromium with a 3 plus charge. The Roman numeral will tell us what the charge is. Now, we go through solving them the same way. So for instance, if we had chromium 3 chloride, okay, it's chromium 3 chloride, if I think about how that would balance out, it's chromium 3, so that's a 3 plus. Chlorine is a 1 minus, so I have chromium 3 plus, chlorine with a 1 minus, so I'm going to have 1 minus, 1 minus, 1 minus. I would need 3 1 minuses to cancel out the 3 positive, and so that would mean I would need 3 chlorine to balance out 1 chromium, and the formula would be chromium with 3 chlorines. If we wanted to work backwards from that, okay, if we want to work backwards, sometimes you're going to be given the formula, something like this. Okay. Sn is the formula for tin. Tin is a transition metal. When I look at the periodic table and I look at tin, tin can have multiple charges. This is going to be, since it's balancing out with bromine, what I want to think about is what's the charge on bromine. So tin, I don't know what the charge is, but bromine is always 1 minus. And if I know that in this formula, the tin is balancing out with 2 bromine, that means it's balancing out with a charge of -2. And if I only have 1 tin in my compound when it's balanced, that must mean that the tin is 2 plus. So the name for this is going to be tin 2 bromide. Okay. Conversely, what if I had SnBr4? This is another tin compound, but if we look, it's balancing a little bit differently. So this is balancing with 4 bromine. This must be a different form of tin. If it's balancing with a -4 charge and there's still only 1 tin, that must mean it's balancing with a +4. This is going to be tin 4 bromide, or bromide. Okay, and you can go through and the transition metals are going to be the ones in the middle. There's multiple charges, and you just need to make sure that they balance. Just as a quick review for Roman numerals, that's a 1, 2 is 2 lines, 3 is 3 lines, 4 is a 1 and a V, and then 5 is just a V. So this is 1, 2, 3, 4, 5. And the Roman numerals are only in the written out, they're only used in the written out name. Not in the formula. Okay, so I'll never use a Roman numeral in the chemical formula. We will only use it when we write out the name. Okay, now lastly, there's one more layer of difficulty here. Some ionic compounds are made up of more than one